Solving radical equations. Our objective is to solve radical equations. Who uses this? Meteorologists can use radical equations to estimate the size of a storm. Let's look at a couple vocabulary words. A radical equation, an equation that contains a variable within a radical. And then an extraneous solution is a number that is not a solution of the original equation. So let's start with the power property of equality. Basically, if you square one side of the equation, you must square the other. So if we had 3 and we square it, and we have the quantity 1 plus 2 and we square that, either way you end up with 9. Let's practice. So we have the square root of x equals 8. The opposite of taking the square root of something is to square it. So the square root of x squared equals 8 squared. Whatever you do to one side, you have to do to the other. So now we end up with x equals 64. You can always check your solution. So the square root of 64 is in fact 8. So now let's try this next one. So we're going to square both sides. So we end up with 36 equals 4x. We have one more step. So we want to get x by itself. So we're going to divide both sides by 4. And when we do so, we end up with x equaling 9. If we check our solution, we have 4 times 9, take the square root of that, and we end up with 6. Take a moment and pause the video and try these next 3 on your own. When you return to the video, the answer for each will be revealed. And there you have it. Some square root equations do not have the square root isolated. To solve these equations, you may have to isolate the square root before squaring both sides. You can do this by using one or more inverse operations. The last few examples we did, the square root was isolated. Notice how in these, the square root is not all by itself. So step 1, get that all by itself and then square both sides. So we're going to subtract 3 from both sides. And we end up with the square root of x equals 7. Now we can square both sides and end up with x equals 49. Let's look at b. Notice how the square root is all by itself. It's been isolated already. We don't have to do anything extra. So we're going to simply square both sides for this one. So we have x minus 5 equals 16. Then we're going to add 5 to both sides. And we end up with x equaling 21. Just so that looks like an actual plus sign there. Alright, so now if we look at c, notice how we have this plus 4. We have to get the square root by itself before we can square both sides. So we're going to subtract 4 from both sides first. And then we have the square root of 2x minus 1 equaling 3. So now we can square both sides. So we're going to square both sides, and we end up with 2x minus 1 equaling 9. So then we can add 1 to both sides, and we end up with 2x equals 10. And then dividing by 2 on both sides gives us 5. Take a moment and pause the video and try these next few on your own. When you return to the video, the answer for each will be revealed. And there you have it. Now let's look at solving radical equations by multiplying or dividing. There are 2 ways you can go about this. So let's look at method 1. You can isolate the variable or the square root and the variable first. So we're going to divide by 3 on both sides, and then you end up with the square root of x equaling 7. Then you would square both sides and end up with x equals 49. Or, since you're multiplying, you can square the entire quantity. And when you do so, you don't forget to square the 3. So it's 3 squared and the square root of x squared. So you end up with 9x equals 441. Divide both sides by 9 and you still end up with 49. Let's try a couple. So in this case, we want to multiply both sides by 3. So we can multiply both sides by 3, and we end up with the square root of x equaling 15. And then we can square both sides, and we end up with x equals 225. So now let's try this one. We divide both sides by 2. We end up with the square root of x equaling 11. Then we can square both sides. We end up with x equals 121. Take a moment, pause the video, and try these next two on your own. When you return to the video, the answer will be revealed. And there you have it. So now let's try solving radical equations with square roots on both sides. So we have the square root of x plus 1 equaling the square root of 3. When you have a square root on both sides, and it's all by itself on each side, we can square both sides. So now we have x plus 1 equals 3. And then you can subtract 1 from both sides and end up with x equaling 4. Notice how in B, both square roots are to the left. So therefore, you need to move one of them to the other side. So we're going to add the square root of 3x to both sides, providing us with a square root on both sides of the equation. So we have the square root of x plus 8 equaling the square root of 3x. Now we can square both sides, and we end up with x plus 8 equaling 3x. We want to solve for x, so we're going to subtract x from both sides, and we're going to have 8 equaling 2x, and then we'll divide by 2 and end up with 4 equals x. So now take a moment, pause the video, and try these next two on your own. When you return to the video, the answer for each will be revealed. And there you have it. Now let's look at an extraneous solution. Suppose your original equation is x equals 3. You square both sides. Now you have a new equation. You have x squared equals 9. To solve this new equation for x by taking the square root of both sides, you end up with the square root of x squared equaling the square root of 9. Well, the action of taking the square root of something, you don't necessarily know whether it was 3 or negative 3. Now there are two solutions. One is x equals 3 is the original equation. The other, x equals negative 3, is extraneous. It is not a solution of the original equation. Because of extraneous solutions, it is important to check your answers. Helpful hint. The equation in example 5 has one solution, but for some equations, all of the solutions are extraneous. In this case, the equation has no solutions. So we have the square root of 6 minus x equaling x. So we're going to square both sides and end up with 6 minus x equals x squared. Now we need to move everything to the side with the highest power. So we're going to end up with 0 equals x squared plus x minus 6. And then we can factor. So we want two numbers that multiply to give us -6, but add to give us 1. So we end up with x, and then we have -2 and +3. We want to set each of these equal to 0. So to set this part equal to 0, we end up with 2, and this one becomes -3. So right now we have x equals 2 or -3. So now let's check our work. So we have the square root of 6 minus 2, and we want to make sure that equals 2. So we have the square root of 6 minus 2, which is 4. So we have the square root of 4, which is in fact 2. So the first one worked out okay. So now let's try the next one. So we have the square root of 6 minus -3, and we want to make sure that equals -3. So we end up with the square root of 9 equaling -3, but the square root of 9 is 3, not -3. So therefore, 2 is the only solution, and -3 is extraneous. Take a moment and pause the video and try these next 3 on your own. When you return to the video, the answer will be revealed. Remember, check your work. Sometimes none of the solutions you originally come up with are actually solutions. And there you have it. Notice how for the first two, none of the solutions that you thought were going to work actually worked, so they had no real solutions. In the last one, however, we ended up with x equaling 4, and that worked out nicely. So that ends our video on solving radical equations.